Right. So first, a couple things about me. So I have worked in a couple companies that have to do with 3D printing. I also volunteered at maker fairs in Prague and around the Republic mostly. At one maker fair, I met the guys from Tech Hackerspace, and I started going. And like half a year later, the plate in our microwave oven broke. So I decided to try and print a new one. So project, I taught myself modeling, and I didn't settle for something basic. So right away, I also learned how to assemble a model from multiple parts, because it was too large to be printed in one go. And of course, the most important thing, branding. So I embossed some logos of our hackerspace and mine as a maker. And I really like that process, and I like that I was able to get to the end of it, and also the method of quick iteration that is quite easy with 3D printing. So I am mostly self-taught. I have also been employed in a startup that uses 3D printing in actual production for electronic enclosures. So I know that it is a practical technology for even for mass manufacture, especially good for startups because of the low initial investment costs. And now I am trying to make it as a freelancer in product design, 3D modeling, and mainly for 3D printing. So I told you about me. Now I'd like to ask a couple questions about you. So who here knows how to read blueprints? Using calipers? This one? Not that much, all right. Have you modeled, 3D modeled before? All right. All right. So thank you for that. Now I have some idea who I'm speaking to, which is important. And also I want to apologize. I am self-taught. I don't have technical knowledge, so some ways in which I'm doing things might not be the right way, but as I see it, as long as it works in the end, the method should not be that important if one is working by themselves. And I mainly use the iteration method. So I often start with a rough design, rough idea, not super precise, and I iterate with 3D printing, where I print the design and compare it to its real life counterpart or the fit and so on, and then I adjust the design for the next iteration. So this workshop is called How to Make Replacement Part, and actually yesterday one of my models broke when my infinite stick that can be 3D printed fell on the hard floor, so it broke off the thread out of this demonic microphone, which is something that I released recently. So I can show how to potentially make a replacement part on that. It threads on the top.
What do you do with it?
It looks cool. That's the most important part. There are infinite uses for a stick, but yeah. So first, we need to measure what broke. So one method that we can use is to measure with calipers. So there are different measuring techniques that you use with calipers. One is the one that's obvious. So you go between the jaws and you push it together around the part. And they have both analog readout at the measure, but usually these days you would use digital calipers, which have the digital readout, which is much more precise. If you want to measure really precisely with this method, you'd want to, for example, measure at different points of the part, because it isn't necessarily even at all points, and also apply even pressure with your thumb, like this. So when you close around, you can use this wheel to apply pressure. The next one is this set of jaws? No, well, protrusions, with which you can measure internal spaces. So you take it and you pull them apart until they are firmly against the part, and that's how you measure internal stuff. Also, you can measure that, and that's what this stick is for. So you go on top of the part and you go down until it reaches the bottom. So that's, now I measured the depth of this. So out of that, you usually jot down the measurements on paper in a rough sketch. So, for example, I'd write hey, I have a circle. It doesn't have to be a perfect circle. It's just for me. So as long as I start modeling reasonably soon after I did the measurements, I know what everything means. So I tend to go quickly, and that works for me. So here I would have the circle, and I would jot down, usually in millimeters, the diameter that I measured. Another method, which is also useful, especially for more flowy shapes, is when for example, if I'd like to measure the mouse, it's a very curved shape, so jotting down all the measurements of this would be really hard and time consuming. So what I can do is take a piece of square paper. This one has dots, but that's fine, and use the known dimensions of the squares as a reference point, and I would trace the shape, right? right? This is rough. I usually take more care, but that's enough. And then I can take a picture. And I'll get it into my computer, and I'll show you quickly how to get it into Fusion practically. So, now let's finally get to the computer, and we can start modeling. So this is the basic view which you usually see when you open Fusion, unless you have a different setup. It's a blank space where you have this cube that shows you how you are oriented at the moment, and you always start with a two-dimensional sketch. So this is where you create a sketch. You select the plane on which you want to put it. That is important for how the model will be orientated when you manipulate it, and Fusion automatically gives you a flat view of the plane you selected, and here you can start using different drawing geometrical tools. So for example, I can make a circle and type 30. Numeric keyboard is really useful for modeling because you can type the measurements easier. Hit enter, and now I have a 30 millimeter, which is the basic unit I work in. Circle. Other tools are lines and squares, and also polygons, which are quite fun. Actually, with a polygon, there's extra thing you can do. You can both write the measurement, but also the number of sides. It is a very important key in Fusion is escape, because right now, if I continue as it is, I am still in the same tool. So I am again doing a hexagon. I have to hit escape now to exit out of the tool to select another one. So you hit escape very frequently when switching between tools. Right, and a very useful function is point spline, with which you can do curvy shapes. So now I'll download the picture, and I can let's delete these examples, and I can insert it into Fusion as canvas, which means it's just a picture. Another way of importing is to import an SVG as a vector graphic. If you do that, it means that you already have the sketch lines in and don't have to make a new sketch, and can work with it with modeling right away. But usually using Canvas is also fine. I'll orient it this way. You can also resize it here and flip the picture. And now what I'll do is that I'll calibrate this picture. So I go to Canvases and right-click the picture and hit Calibrate and select 2 points. Right, and I know that this is let's make sure. This is actually 7.2 millimeters, huh? Okay, one shouldn't assume. And now the picture is scaled appropriately to how I want the actual measurement. And with this trace, I will then go back into the sketch. Never mind, it doesn't show up because I did it afterwards. But I can swap their places, and now if I go into the sketch, it will show up. And here I can trace the shape with fit point spline by selecting different points along the way.
Question, what did you do this is SVG now?
This is a JPEG, right?
This is still JPEG?
Yeah, this is a JPEG, and I'm drawing on top of it. So I'm making the vector graphic in the sketch tool. Right. So, for example, I would usually, when doing this method, I would first do all the straight lines. Let's say here, and then connect those with splines. Also, feel free to interrupt me with questions at any time. I don't mind. Let's do this one. Right, and usually you would line it up until it fits approximately. If it doesn't, right, like here, I'd stop it at this point. So now I need to hit Enter for the curve to solidify, and then go on from there with another one. There we go. And you go and you go as far as you can when it lines up approximately. When it stops, that's when you put down another point. Right, let's say that's good so far. And you can also adjust it afterwards. with clicking on the line, right click, and insert spline fit point. You put another point on there, and you can drag it around. Right, so you can, with enough points, you can adjust this to be almost any shape. Now let's quickly finish it and close it, so we actually have a profile that we can work with. Right, just roughly, and now it's closed. So now this can be extruded. However, first I'd like to show you one simple trick. Very often, you would have a profile that for some reason that you don't know is not fully closed. And often, it's not very obvious. See, I'll remove the coincidence here and move the points away just a little bit, right? And when you look at this, in this scale, you don't know. Why is it not a profile? Where's the hole, right? So some of you may notice one indicator, this is white, but in a busy sketch, it might not be as easy to find. So what you can do is draw a line across and move it until it's no longer an enclosed profile. And like this, you can narrow down the area where it's broken, and you then look at the points, zoom in, and either make them one by putting the coincident constraint on both of them, which will move one of them, so they're together, or you can connect them with a line. One important thing in modeling, which is why it is sometimes frustrating, but sometimes also fun, is that often in these programs there pop-up errors that you don't know what they mean and don't know why something doesn't work. But there are usually always multiple approaches how to model a feature. So there's usually always some other way that you can have the same result, and so often you can troubleshoot when something breaks by doing another method. So when I want to start doing 3D stuff, I click Finish Sketch. Now let's turn off the picture. We don't no longer need it because we have traced the shape. And now I can move around. Moving around is either by grabbing the cube or with the most important key combination. I was really frustrated by moving the cube around all the time before I learned it. You need to hold Shift and the middle mouse button to rotate around in Fusion. Now I can select the profile and select Extrude. Usually I hit E, which is the key for this function. And now I can either do it with an arrow, I can type in the number, I can select where it starts, so either from the default, which is from the sketch, from the profile plane, or I can say start 2 millimeters offset, so it'll start 2 2 millimeters higher. Or I can say start from another object. I don't have any other object right now, so I'll do something else. Right. Okay, and let's say I want to start from this face. So I select object, select the face, and it'll start there. This is also important to use these functions because Fusion remembers what you've done in this timeline, and so you can actually go to the previous steps and adjust it. So for example, I can say now 50 millimeters, and Fusion attempts to recalculate all the steps with the new data. So, and because I selected from object instead of a set value, this is now starting from here, from the 50 millimeters instead of the 70 millimeters, whereas if I had start from let's say offset 30, and now I'll change it. Well, I change it exactly as before, so let's change it like this. It stays the same, right? This didn't move. But when I selected from object, it was dependent on how high this plane is, so it moves together. All right. Let's see.
What did you do to get the top one? Did you do a copy paste of the bottom one?
I extruded this again, the profile, and I started from an offset of 30 millimeter above the profile plane. So also you can have different ways to extend. So either you can have it 50 millimeters ahead, or you can go, for example, to object, right? So now it goes from this offset down to this face. Or you can have all, which is usually useful if you want to cut through the whole model. So for example, I'll do another sketch, a circle. I'll extrude it, and either I could do like a drag like this to go through the whole model, or I can select all, and that automatically like makes a hole through all of it. Here are the different operations you can do with extrude. One is join, which makes a new body that fuses with the other bodies that it will be coincident to. Or you can cut, which means it'll subtract the extrusion from the bodies that it goes through. Or intersect, which means it'll leave only the intersection of the two bodies. That one is not that frequently used, but it is useful in some cases. Or you can have a new body and have two different bodies. So now instead of having one, which would happen with join, right? So now it fused together. I'll have three different ones, and I can move this one around, for example. Right? So I have different bodies. And what I can actually do right now is make a hole in this body with this one, with the tool combine, where you select the body you want to modify and the body you want to use as a tool. And then you either say join them together, cut, or intersect, which is equivalent to what we just talked in extrusion. And you can either keep the body that you used as a tool, or if you don't need it anymore, you can unclick this and it'll disappear. It was used just for this operation. Let's illustrate two different approaches to modeling, let's say, a shape like this, a cup. I'll do a really simple one. So you can, let's say we delete all of this. Let's say I want to start from the bottom. So let's say this is like 60 millimeters. We are just having an example. And let's extrude it up. Say 100. And then I'll return to the sketch. Either do like 50 if I want the wall to be 10, or I can actually, instead of doing a new circle, I can do an offset and say -5. And that is again useful because if I now change it to 70, it'll automatically resize. Whereas if I had the new circle, I'd now have to resize the other circle as well. And now I can extrude this inner circle. Let's say from the top to the bottom, but with an offset of -5 millimeters to ensure that a bottom remains there. So now I have a simple cup. Another approach that I could have taken is also to approach where I first extrude both of these 5 millimeters up, and then I extrude just the inner circle from the plane 95 millimeters up, and I have the same shape. Another approach is not to go from the bottom, but to do a revolve sketch. where I'll trace half of this profile and revolve it around. So let's do this, 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 and this. What I am able to do, either go with precision right away and type in the measurement when I'm making the lines, or I can have a rough shape and then do the dimensions in later. Here we have some bits of lines which we can remove precisely by using trim, which is under the letter T, and trim removes just the portion next to the next intersection of lines. So now it's clean, and I didn't have to go precisely. You can also drag the mouse across with trim to remove multiple at once. Then there's the dimension tool, which is under D, and with this you can dial in the measurements. Say this one is 30, this one is 5, and now I have like a horizontal cut through here, and I will use the revolve function to turn it around this axis, and now I have the same shape. So this demonstrates that there are usually multiple ways of how to model something. Another approach is also, let's say, I will right. I will do the whole thing. I'll do another cylinder, a new body, say 95. No. A new body. I'll now move it 5 millimeters up. Right, I have two different. Oh no, didn't hit enter. So let's try again. 5, new body. Okay. Right, I have two different bodies. So let's move them like this. And I can now use the combine tool to cut this body with the other. And again, we have the same shape. All right. So a useful tool which I would use to create the thread on a cylinder for this part is the thread tool, which I think at least for some time, I don't know if it's changed, but even isn't included in Inventor. And I can select the size of the thread, what profile I'm using. I usually use isometric, and its size. Usually it's right hand, and you can either leave it like this, which is the default setting, which means it's only cosmetic, and it reminds you to make a thread later in the manufacturing process. But actually, with 3D printing, I quite often use modeled thread, which will cut it into it right away, so it can be printed. Right. So on this model, I use threads. They are big enough. I put in tolerances, so they work quite well, even with 3D printing. With a smaller size thread, you run into a danger of it wearing out with multiple screw-ins and screw-outs if it's 3D printed. But if you're not expecting frequent screwing of the thread, then it's fine to have it to make it 3D printed, especially out of resin printing SLA that makes quite fine threads. However, if it should be more durable, you want threaded inserts, which you buy metallic threaded inserts, and you can actually melt them into the plastic with a soldering iron, and they so you make a hole that is slightly smaller than the threaded insert. You heat it up with a soldering iron, and because plastic melts, you push it in, and it then melts in and stays in quite firmly. All right. So, any questions about? Okay. No. First, let's also show the hole tool, which is actually similar to the thread tool. So let's make a hole on this point, and with this, you can select different distances. You can do a counter bar or a countersink automatically, right? You can have it with clearance, and I usually use the tapped setting, and let's say make it through all of the part, and make it bigger than 2.3 millimeters. That's quite small. Like 15, so we can see it. And you can then dial in the other measurements as well on using this blueprint. And again, if you want it to be printed, you need to hit modeled. So the threads are modeled in. This operation, if you're doing a long thread, sometimes it can be more computationally heavy. So sometimes this takes a longer time to show, depending on your computer. And usually what I also do to threads to make them better work with 3D printing is that I use a clearance of 0.1 millimeters, which I do by selecting the faces. And because it is a continuous thread, it selects it all throughout. It's all one face. And I use the press pull function, which is under Q, to make it minus 0 0.1 millimeter. And yeah, now it's thinking. It's doing a preview of how it'll look. Right, so I type in minus 0.1 to make it smaller. This will make it a bit bigger. Right. So you sometimes you want to dial in the tolerances in iterations, but 0.1 on either on just one side or on both sides of the thread, on both the inside of the thread and also what you are threading in of 0.1 works quite well in my experience. Okay. For 3D printing, you also want to use chamfers, which cuts off the edges in a straight way. You can also use fillets, especially on parts that are more higher. But the problem with 3D printing is that on curved surfaces, the different steps of the layers being put down are more prominent. Also, if you use chamfers, growing a model from the bottom up, you usually don't need supports under the material if they are at 45 angle, because they can build on itself. So you save on material. That's for example why this model is hexagonal, because we have this chamfer shape here, so nothing needs to be under it when it prints. Another important element is also how you will orientate the model when printing, because the models have higher strength in the direction of the layer lines. So I printed this in this way because it's easier to print. Because it's in two halves that sit flat on the bed. It doesn't need many supports, but this means that this is actually weak because the layers are stacked like this, so it's weak to this kind of force, this kind of motion. So that's why I designed this part to be printed like this. So the layer lines are perpendicular to the bed, so it's stiff in this way. If I printed it like this, it would be weaker. So we don't have much time left, so I'll be skipping over some parts. Yeah. There's the timeline is quite useful, but sometimes when it recounts something in a hard model, let's say this one. Let's say I change dimension here. it can result in a lot of failures and a lot of troubleshooting. So actually, with this model, it got so frustrating that some things I have given up on changing the previous parts and actually just did new steps instead of adjusting it in the past. So there will be probably a bunch of red and yellow errors after this operation. It's now computing the whole model again. All right. So these are groups. So the timeline is smaller, and that's good for collaboration and to have the model divided into sections. So for example, for the different components, you have the steps grouped together, so you don't have to scroll around in the timeline too long. All right, and the last important thing to talk about with Fusion is money and licensing. Fusion has a free version, which I am using, and that works quite well. It has a couple limitations. You can have only 10 models in the editable state at the same time. It's just an inconvenience, basically, because at any point you can put them back from read only to editable. So you just need to put older models that you're not working into read only, and if you want to edit them back into editable, it's basically just an inconvenience, and it can be worked with quite well. Also, the basic license is made to be harder to find on the website, so it's not always obvious that there's a free version. So there still is. Don't get discouraged.
How are the operating system? What's the
It's primarily Windows and Mac. On Linux, it can also work, but it's only like a web-based version, and you need at least a student license. There is or paid license. There's no free version on web.
There's nothing like a hobby license, or what's the name of this free license?
Yeah, like basic or hobby. There is also a startup license and student license and different like free licenses. But for those, you need to go through a bunch of bureaucracy and prove that you are worthy of having the startup license, that you haven't made this much money and you have a company and you need to have it approved by Autodesk.
So without student license, there is no freebie on the Linux?
No.
Oh, okay.
Only if you virtual machine a Windows. Right, so now you can see there are a bunch of errors. This is broken. This is broken because I used some of the splines and the flowy shapes and so on. There are also different modules. Even in the base version, you can easily switch to a rendering workspace and make nice renders with different lighting. And you can also prepare CNC routing. However, in the free version, there is some artificial limitation on the speed in which the milling bit can go and stuff like that. But Fusion is quite versatile. It also has, in the higher versions, it has like access to generative design and simulation capabilities, but you also, how that works is that you buy like tokens that you use for this computation, and it goes through the cloud. Also, Fusion is an online service that has an online component where you can share things easily. People can view the models outside of Fusion and so on for collaboration. But so that is quite useful. It syncs automatically, but that also means that without the internet, some capabilities of Fusion can get limited. So it's good to be online when working with Fusion. It's not strictly necessary, but it's always better. So thank you very much for attending. You can visit my profile on Printables, where I have some models, and you can also visit illuzon.me, which is my personal website. I'm open to any questions. I'll be glad to do something for you. Not right now. We are out of time. I think the next workshop is going to start.
Are you running this next one?
No.
No.
So yeah.
I'll wait for you next time to talk about.
Mm-hmm.